All right, so we're going to get started. So I'm going to talk about securing your Node.js and single-page apps, pretty much JavaScript applications. If you want, you can follow along here. If you go to bit.ly/JS security, I'm going to move pretty fast, so follow along, and you can find links there and stuff like that. So my name's Mark Stuart. I build large-scale JavaScript apps at PayPal. So we use Node on the back end and Backbone on the front end right now. We're looking at Angular and other stuff. But pretty much I work on consumer apps. So like after you log into PayPal.com, we have a new experience there. It's all with, Node and stuff. Pretty much use JavaScript throughout the entire stack. So I'd like to know, how are you guys using JavaScript? Are you guys using Node at all at your companies? Awesome. In production? Yeah. Nice. Cool. And then what about like client-side MVC frameworks? Are you guys using like Angular or Angular people? Cool. Backbone still? Yep. Nice. And then React? No React people. Okay. All right. Yeah. So anyways, so I have a bunch of stuff about underscore Backbone, a little bit on Angular, but mostly Node. But it does apply to client-side frameworks too. So you're wondering why security? I actually didn't used to care about security much at all until about 8 or 9 months ago. Being at PayPal, we're a huge security target. Like hackers always try to find cross-site scripting vulnerabilities for our bug bounty program. So at the time, I was working on our checkout product. That's also built in Node right now. We're like ramping it up. I think it's like 80% of the US traffic right now. But it wasn't until I was just browsing Hacker News one night and saw someone posted a news article pointing out a security vulnerability on code that I worked on. And so it sucked. It was like the worst feeling ever. And then, after that, I just started to kind of read more about security and really just secure my app. So here's some examples of some tweets that you could also find if you just search like PayPal cross-site scripting. Ouch, glaring, obvious cross-site scripting vulnerability in PayPal. Just what you want from a financial transaction merchant. PayPal's Express Checkout has the exact same vulnerability. Token fixation, OAuth 1 had a while ago. That's the app that I was working on. Under the microscope, the bug that caught PayPal with its pants down. But the message here is it's not just PayPal, it's also your company too. PayPal's a huge target, but there's also vulnerabilities in your apps too. Here's an example of LinkedIn. LinkedIn is fixed for cross-site scripting issues that could have allowed attackers to steal users' credentials. Yahoo gets hit by a nasty cross-site scripting flaw in its comments and stored cross-site scripting vulnerability in Google Drive. Really, so the message is it's your company too. It's not just PayPal and all the kind of glamorous companies, stuff like that, like the ones that hackers like to attack. Okay, so let's take a step back. So if I were to give the scoop on security nowadays, it's pretty much the same vulnerabilities have existed for years, like 10 years. And there's absolutely nothing new. So this is the point where I would just walk off stage and you're like, oh, cool, thanks a lot. I'm glad I'm glad I came to this talk. But it's really the same vulnerabilities have been around for years, but it's just a different beast with JavaScript. Especially when it comes to Node. Node's like this new shiny new thing that it's like the best platform to build a web app nowadays, right? Arguably. But people often forget that the same vulnerabilities have existed for years, and we need to solve those problems again with Node, right? They've been solved in Spring and Java and stuff like that, .NET, but Node, people are just starting to think about it now. So definitely keep that in mind. Okay, so the first part of this talk, start talking about Node, and then we'll kind of dive into client-side stuff later. So the first rule, how to secure a Node app, know what you require. Sounds simple, but NPM has about 88,000 modules now. It's huge. Here's a chart from modulecounts.com. They actually count how many modules are in each of the package systems. So as of July 1st, NPM is now the largest package manager. It's bigger than Maven. It's that blue line you see right there that has like crazy trajectory. Really, it's not slowing down at all. NPM is huge, and it's really a big factor why Node is winning. But it's also a double-edged sword. So we have a great developer ecosystem, except anyone can publish anything. There's no one saying that you can't like publish a vulnerable module. Let's say someone published a module called, I don't know, like YouTube API or something, some common term that someone would search for, and then they had like maybe some malware in there that, I don't know, kind of intercepted traffic and sent it back to their server. Someone could totally do that. There's no one preventing this. So definitely know what you require. Require reputable modules, not just some random something off the shelf. So just be aware. The next rule, Node is still JavaScript. People forget that. The exact same client-side vulnerabilities still exist on the server side. So here's a famous rule from Doug Crockford and all of his JavaScript books. Eval is still evil. If you still use eval in your code up on the server side, it's terrible. It's just as terrible as it was before, except way worse because it's the server side. So yeah, basically the rule is if you use eval, you'll be choked by Crockford's Vulcan grip. So don't. Rule number 3, don't run Node as root. Running as root is reckless. If you're compromised, terrible things could happen. Someone could steal your SSH keys, read and write files, execute binaries, cause the server to hang, tamper with routes, inject more cross-site scripting, steal session data, crash your server. So if not root, then what? Create a user specifically for your Node process and give it restricted permissions. There's lots of docs out there on how you could do this. A lot of people don't do this. They run Node as root, sudo everything, and yeah, you have access to everything. It's not good. Okay, rule number 4, use good security defaults. If we remember, Node is just a set of really bare bones modules. Here's some of the, well, this is a subset of what Node offers, but it has an HTTP module, file system, process stuff, operating system, buffers, and so on. It's really just bare bones system stuff. And Express, I'm sure a lot of you are using Express or Happy or something like that for your web app framework, but it's really minimalistic. It's just a router. It just serves requests. It will not provide you any security at all. Pretty much just creates sessions, sets cookies, and serves up requests. That's it. Yeah, so it does very little to secure your app. In Express 3, a version behind now we're on 4, but Express 3 used to include an optional middleware for protecting against CSRF attacks, but Express 4 took it out. And now it's in a module called csurf. Once again, CSRF is just like one of many attacks, so it does very little to secure you. But that's okay. So there's lots of other supplemental frameworks. At PayPal, we introduced one called Lusca. There's another really good one called Helmet. We'll talk about those in a second. So anyways, drum roll. Kraken.js is a framework that PayPal put out. It's basically our little sugar on top of Express. So you could use Express, require in Kraken. Pretty much just provides good conventions for large teams. So if you're working in a large team environment, more than 10 people working on an app or something, it's really good. Provides you security out of the box, internationalization. Like if you're pushing your app to more than one country, like outside the US or something like that, then Kraken's really nice. Yeah, so it's pretty much our enterprise-grade Express. So one of the Kraken modules is called Lusca. That's a security module. Kind of talk about that. So you could use it with just plain regular Express. You don't even need to use Kraken. Just require Express, new it up, require Lusca too. To configure the security stuff, pretty much just if you use Express, you're pretty familiar with app.use. It's how you configure all your middleware and stuff like that, like cookie, body parsers, stuff like that. But if you use Lusca here, it'll get you, I'd say, like 80% of the way there. So definitely use good HTTP headers, to protect you from CSRF attacks. Use CSP to protect from cross-site scripting. X-frames, so your site can't be loaded in an iframe. So I kind of want to interrupt right there. I want to make sure we're all on the same page about CSRF and CSP. I didn't really know about them until about 8 months ago. So anyways, CSRF is when you trick a victim's browser into making malicious requests. So all you need is a valid cookie from some website. So this is kind of how it works. So if you're a user and you go log in to yoursite.com, you authenticate, you get back a cookie. Totally legitimate. So if that same user goes to some other website that's been compromised, like hackedsite.com or whatever, so if that hacked site has content in there, it can instruct the user's browser to make requests at another website. So here, a user's hitting hackedsite.com, they're getting back a malicious payload, and the user still has that cookie from the legitimate website. So let's pretend in that malicious payload, let's say they send back some HTML here. A form is pointing back to yoursite.com/webapp/transfer funds. And we're going to send some money to hacker@hacker.com. So let's go back. So the user hits hackedsite.com, gets back that malicious payload, and instructs the browser to make a post at a legitimate website, yoursite.com, to transfer funds. And that's all possible because he still has the cookie. So if we think about it from our perspective, we're building a Node app. A request is a request. And your server doesn't really know any better. It's going to serve it up. So if only we had a way to ensure requests were legitimate, like they came from your website, not some other website instructing a browser to post at you. So if you use this Lusca CSRF middleware, it uses the token synchronizer pattern. It's basically your server will create a random token per request using some crazy Node crypto libraries. It adds the token to res.locals. If you use Express, this is like some model that your templates can use. You dump the token on your page, so usually a hidden form input here. And then you send back that token with every post, put, or delete request. Any request that's making modifications, so not gets. If you're using jQuery, this is how you could override the headers here. So if you're making AJAX requests, it'll tack on this token as part of the HTTP header, just so you don't have to like inject a hidden form element or anything like that. Okay, so we send the token back up to the server, and we verify if that token's correct. Otherwise, we return a 403. So if we back up a bit, this just ensures that requests come from your website and no other compromised website. So CSRF cross-site request forgery. So another really big feature, this is what I'm most excited about, CSP. CSP is really awesome. I hope it ends up working in the end, but it's basically just a whitelist. So here's an example of a content security policy. This actually gets dumped on your HTTP headers. You whitelist all the sources that, all the sources that your page loads data from. So under script source there, it could only load scripts from itself, or maybe you could whitelist your CDN or something like that. This ensures that, so let's say some content was injected on your page somehow, and it was pointed to hacker.com/keylogger. Let's say someone wanted to start up a keylogger, log all key events, and send it back to their server or something. It would actually be rejected right here, and you would get this error. So it really just protects us against cross-site scripting. But the really cool part is you could also define images here, fonts, connect sources for those of you using WebSockets, like Socket.io and stuff. I could do iframes, Flash, all kinds of things. And that's provided with. Oh, what did you say?
You expire your CSRF?
Yeah. Yep. I'm not sure, but I think it's like maybe a couple hours or something, like 3 hours, something like that. Yeah, sorry. But with CSP here, that's kind of how you define it, just as a piece of middleware. You could also define it in configurations, so it's not one long line of code. So the cool part here about CSP, at the very bottom is report URI. So that will basically, it's basically an endpoint that, like whenever there's a CSP violation, like before it was like keylogger.js, that error will actually get logged back to your server. So it's kind of cool because you could do some preventative things, like you could be proactive and get reports of people poking around and stuff. So you could kind of patch up that hole, I don't know, before something really bad happens in the future. Some other features, HSTS basically just ensures HTTPS traffic, so there's no man-in-the-middle attacks, or helps prevent it. Xframe just prevents others from loading your app in an iframe. This is particularly important for PayPal. Like if you try to load our homepage in an iframe, you'll get denied. It's really good for clickjacking attacks. So let's say we were on some compromised website. We could load up PayPal in an iframe, make it invisible, and we could have it like track the user's mouse. I don't know, so as they're clicking on things on this other website, they're really maybe clicking submit on a PayPal send money form or something. So basically we're ensuring that other websites can't load us in an iframe because they could do some pretty bad things. And then, I don't know if you remember, but P3P, it's like an obscure IE8 thing, but you get it for free, so why not? Yeah, I mean, that's really all you need to get the correct security header set. It'll really get you like 80% of the way there. But there's a lot more topics, so let's talk about that. Okay, so now where were we? HTTP-only cookies. So HTTP-only cookies prevent session hijacking. For those of you familiar with Express, this is how you kind of, I guess, create a session cookie. Like when your user first hits your Node app, it creates a session cookie with a secret and dumps it on their page. But a lot of code snippets out there, like on Stack Overflow and stuff, they don't have this HTTP-only true flag, which makes a really big difference because of this. So if an attacker somehow got content on your page and maybe they were reading off document.cookie, sending it back to their server so that they could hijack someone's session, you can't do that with that HTTP-only flag there. If you do document.cookie, it'll just empty string. So you can't steal it that way. So I guess bottom line, if you're using Express, make sure, go check your index.js file, make sure HTTP only true is there. Okay, next rule. Handle errors or crash. So, Node's still JavaScript. When you get an error, your process is dead, which isn't good. So if you get an error, your process will exit unless you handle it. So unless you're using like promises or listening for an uncaught exception event, your process is going to exit. It's basically a denial of service attack, or it can be used that way. Like if you have something pretty obvious and maybe a hacker knows how to crash your server, they'll do it over and over and over and affect your business and maybe your bottom line, right? So catch your errors or just restart your process as fast as possible. At PayPal, we use Node in production. Our stuff crashes all the time, just for like developer, bugs, stuff like that, not null checking. But we have like 50 servers up, and if one process crashes, we have forever, and then it just starts up immediately. So when your app crashes, you won't suffer much downtime, maybe milliseconds or whatever. But yeah, catch them or restart. Next rule, scan for vulnerable modules. This is probably one of the best features, or best tools, I guess, you could use to prevent against insecure modules in Node. So there's this group called the Node Security Project. It's led by Adam Baldwin, a company called Lusca Security, and others in the community. Their goal is to audit all modules in NPM. So if we remember, there's around 88 or 90,000 modules. So it's a really ambitious goal, but they seem to be auditing well-known modules, and they contribute patches. This is the list as of today. There's actually one from August 6th. We'll get to that. That was a crazy security patch, or security hole that was patched. Anyways, yeah, so another goal of theirs is to educate others. If you want to use this, so there's this grunt module. I don't think there's a gulp equivalent right now. You guys could go build it. But if you npm install grunt nsp package, and you do grunt validate package, this will actually scan your package JSON and all of its dependencies to find vulnerable modules. So here I'm running the validate package task, and I found that happy, I've 2.0 installed here, and it has a vulnerability, and it points a link there to the exact vulnerability that it has. So this is really powerful. At PayPal, as part of our CI, we actually run this task. Before any app goes to production, we'll scan and make sure that none of our modules have any vulnerabilities, right? Because if it makes it out there to production, it's kind of reckless, right? This is a nice preventative measure. And it's really just one line of code, so add it to your CI. Security can definitely be automated. So ESLint, a lot of people haven't heard about this yet, but it's something that Nicholas Zakis is working on. It should take over JSHint and JSLint. It's my prediction. It allows you to write your own custom rules too, and it's super easy to do that. You could, like for example, you could create a rule to ensure that eval isn't used in your code, or in Express, like if you use method override before body parser, there's a CSRF. You could still use a CSRF attack. So yeah, you could just write custom rules. Some security rules are already written by members of the community, so yeah, check that out. Really the message here, security can be automated too. You saw it was just one line of code and it could scan your whole project for vulnerable stuff, so it's easy, just do it. Make it a part of your CI. Next rule, update your dependencies. It sounds like the most simple thing ever, but people just don't do it. So August 6th, just like a week and a day ago or something, there's a big vulnerability discovered by the Node Security Project. It's a denial of service attack with a module called QS. Probably a lot of people haven't heard of it, but it basically gave attackers the ability to crash your server with one line of code. QS is a query string parser. Sounds kind of simple. It could parse strings like this. If you parse A equals C, it'll give you a nice object there. It seems kind of simple. Here's another. It could also parse arrays, and this is actually where the vulnerability sits. So someone found this out, but if you try to parse this query string, it actually creates a really large nested array of null objects, and it'll cause your node process to run out of memory and crash your server. So this is the problem. QS is used by lots of popular modules, one being Express, Happy, Restify, Body Parser, Wrestler, Super Agent. You've probably heard of at least one or two of these, I'm guessing. The problem is most of us are using Express. And the vulnerability is if you just pass this as your user agent, rather than Chrome or IE or something, if you pass this, your server will crash. Before it hits any of that security middleware, anything like that, it just dies because Express uses Connect. Connect was using an old version of QS. Or if you pass this just as a query string param and just send it at the server, it's dead, which is really bad. It runs out of memory and you get this error. But the good news, it's been patched, but you're probably running an old version still. So update your dependencies. Like right now, check what version of Express you have. I think it was patched with one of the later 3.0 versions, and then it's definitely patched for 4.0. One of the ways you could kind of, keep on top of this, you could add a badge to your README. So at PayPal, this is a project we work on. We also have this internally, but see those like badges right there? It's like green, yellow, red, basically. If it's a red badge, it means you have lots of dependencies out of date. It's like you'd be surprised. Like if developers see a red badge, like they just want to see it green again. Like the second our stuff turns red, some developer on the team updates everything and it's green again. It just annoys people. Just put it there front and center in your README. And if you click that badge, it gives you a nice kind of display here of exactly what version you have of all these modules and what's the latest and stuff like that. If you go to David node-dm.org. If you just add that one image there in your README, you can get a badge too. It's pretty easy. So let's recap on Node. Know what you require. Node is still JavaScript. Do not run as root. Use good security defaults, and security can be automated too. All right, next. Client-side JavaScript. First rule of that, escape everything. Don't trust literally anything. Like if you have, I don't know, if you're using some templating library and you're like user input, if you're kind of injecting that in your page, some could easily just inject some malicious code. Or, don't trust backend data either. Kind of talk more about that. So, yeah, so we're all talking about content injection. It's the cause of almost all client-side attacks. Browsers are kind of stupid, if you remember. They're instructed on what to do, and they'll execute any code that's sitting there in the payload. Cross-site scripting sucks. It's everywhere. If you remember, PayPal, LinkedIn, Facebook, Google, Twitter, right there. When I talk about escaping, this is really what's going on. So let's say malicious payload like script, hacker.com/session hijacker.js was injected on your page. If you escape that, it's now just a string. So it would be outputted, but it's not executable. Your browser looks at it, and it won't go fetch that script. It'll just be a string of text on your page. So it basically swaps out characters for HTML entities, and so it could still be rendered, but it's just not executable. So you should escape both user input and backend data. A lot of people don't escape backend data, but backend data is usually the worst because other systems in your ecosystem could let malicious data in. Like PayPal, for instance. I'm working on one app, but there's I think there's like 40 other Node apps in production right now. If one of those Node apps, I don't know, hits some kind of a common web service that I'm hitting internally, and they don't sanitize stuff on the way in, and my app pulls it out, that malicious payload will be injected inside my app. So don't trust backend data, especially if you're a bigger company and you have multiple apps in your ecosystem, because one of those other apps probably let some malicious stuff in. Yeah, so just don't trust backend services to escape properly either. Be a good citizen and make sure data is sanitized before storing it too. Okay, so I kind of want to explain that whole database thing again. Persistent or stored cross-site script is what I'm talking about here. So here's an example. So an attacker up there in the top left, let's say they fire off a put like they're editing their account, and they say maybe their first name is some kind of a script or something, something malicious. Now each victim that later pulls out of their address book that attacker's first name, that script will be injected on their page. So it's really bad when malicious code's stored in your database, because each time it's pulled out, it happens over and over and over. It's like the worst kind. So this is also how the TweetDeck worm got started. So this was like, I think it was, okay, there it is, June 11th. So here's the tweet that crashed TweetDeck, and Twitter had to take them offline and stuff like that. This tweet caused 76,000 retweets. It's a really small snippet of jQuery too. If you look at it, so he wrapped this whole tweet in like a custom script, basically so he could select it later. But basically, this script will select itself. It'll grab the parent of this tweet, probably a collection of tweets, and then so it finds an anchor tag here and clicks it. So I'm guessing what's going on here. Basically, just clicking the retweet button over and over for whoever. So this was a problem for TweetDeck. It's a Twitter client. As people were scrolling through their tweets, you'd see this. It would like pop up on your page, and the retweet button would be clicked. And so it just spread over and over. And this caused so much volume, it actually took TweetDeck offline. Yeah, so they had to temporarily take down all their services. And actually, Twitter had to shut TweetDeck off too. So really, it's just one tweet 2 months ago. And TweetDeck didn't have escaping for this. So how do you escape? On the client side, there's DOM Purify and Google Kaja. A lot of security experts like Kaja. DOM Purify is kind of up and coming. So if you use DOM Purify, just pull down their library, sanitize any dirty strings. They also have a require.js and AMD module for those of you using that. Node, not quite yet. It's coming soon. But for Node, there's a lot of other sanitizing libraries. I think there's like 5 or 6. We were using Google Kaja. Found some problems with it. We were contributing some bugs back. But right now we're using like one called like Sanitize or Sanitize HTML. Like, yeah.
So the browser actually will escape for you if you set text nodes.
Oh, nice.
So then it's much faster,
Mm-hmm.
and it isn't going to like. We often screw up escaping code, but the browsers they're very good at it.
Yeah.
If you set a text node directly, inner HTML, if you set the text,
Right.
it will do as well.
Yeah, so I think, so is it right, like jQuery, I think, like when you use like .html, it actually like uses like a pen child and .inner HTML, right? They don't use text nodes, I think.
Correct, 'cause you might
Okay.
be inserting HTML.
Right. Okay, cool. Thank you. Next rule, know your templating library and use it properly. So first example is underscore templates. I want you to look at these 2 lines and spot the difference. So one of these lines of code escapes and one does not. Actually, that top piece of code does not escape, and that's copied and pasted everywhere. If you could Stack Overflow and stuff like that, everyone uses the equals example, which isn't great. I really wish underscore would escape by default. A lot of other templating libraries like Dust does escape by default. It's what PayPal, LinkedIn, and a few other larger companies are contributing to. But of course, there's a problem with Dust. So here's a simple if statement. We're checking if a card type is equal to Visa, and then we're going to output some kind of a list element. But if uses eval internally, not good. So here's how you could crash your server with some inputs here, right? So Dust runs on the client side and server side. It's one of the reasons we chose it. Yeah, so basically, if you kind of match this model with this template, your server will die. But I mean, no one really writes templates this way, compares user input to user input. So it is kind of a rare scenario. But I'm sure there's people who are way smarter than me that could find problems. So yeah, if you're using Dust, don't use if. Use EQ. Or you can use if. There's this library called Dust Motes. And instead of like if condition, you use if test. It's a lot, it doesn't use eval. It kind of tokenizes it and figures it out. Next rule, upgrade your front-end dependencies. So there's a tool just like Node, basically. It's called retire.js. So look at these libraries here. jQuery 1.9, I think, was like a 1.5 years ago or something. You'd be surprised how many people are using a really old version of jQuery, like 1.7 or something. Just update your libraries. There's also stuff in Angular here, older version of Handlebars, YUI, Mustache, Ember. Maybe some other libraries you're using, like some random jQuery plugin is also vulnerable. So there's also a grunt task for this. It's called grunt retire. So if you run grunt retire, it'll scan all your JavaScript code basically, and it tries to guess which version of jQuery you have. It's kind of good at it, kind of not. So there's false positives, but here, if you had jQuery 1.6 in your project somewhere, it would catch it and link to a vulnerability advisory. So basically, you should automate front-end stuff too. It's really just one line of code. There's no reason it can't belong in your team's workflow. Just add it. Just add it to your grunt file. Just run it as part of your CI. Just do it. OK, so security rules of thumb. No matter what you do, someone will always find a way in. They'll always find a way to hack your site. But you'll get 80% of the way there if you choose libraries with good defaults, like Lusca or Helmet on the server side. Sanitize data coming in and going out. Definitely escape markup that's going to the client side. I would sanitize data before you put it back in your database. A lot of people don't say that, but just be a good citizen, I'd say. Because some other app in your ecosystem might get malicious code from your app, and it'll cause them problems. Update your dependencies. You could do this on the server side and client side, we saw. There was some grunt tasks to help you out with that. If you're using Gulp, yeah, sorry, but yeah, just write one then. Automate security too. Okay, so you're thinking about this talk. You're like, man, I would never use Node in production. It's so insecure. But the message here, it's like, Node it's still kind of immature, but Node is awesome. It's enterprise ready. We're using it. Yahoo's using it. Walmart's another really big company that's using it. We're all using it. We're all contributing together. So you're not alone. But we really just need to write better, more secure apps. Like Node is no longer just a toy, or you don't need Node just to run grunt, right? It's like if you're building an app, make it secure, make it really solid and good. Yeah. Thanks. Actually, one more thing. Sorry. We're hiring. Yeah, so we're hiring full stack JavaScript engineers. If you haven't quite coded with Node, that's okay too. Yeah, so I mean, we're really one of the only companies using Node at large scale. There's Walmart, Groupon, and Yahoo, or some other really, really big Node shops. Yeah, so if you're interested at all, come find me afterwards, tweet me, whatever. Cool, and then there's contact information. Yeah, thanks. Any questions? Yep, there you go.
Do you have any good libraries to do kind of role-based security type stuff in Node?
I'm not too sure. We use Passport, and we have like some custom. What do you call that? Like a custom strategy for authentication, but I'm not too sure if that supports roles. Yeah, sorry, not sure. Does anyone else know the answer? Like any, I don't know, good modules to handle roles in Node? Yeah, I'm not sure. Yeah. Yeah. I'm not sure. Sorry. Question here?
How do you handle anonymous lists? Like if a web browser can load anonymous lists to APIs, but if someone sees that and hammers it or scrapes your data or other things like that.
Yeah, we use rate limiters. I don't think there's a public module for that. We need to publish that. Definitely for rate limiting, like if someone's like tapping your website, thousands of times per second, that would definitely cause problems. As for like kind of unauthorized gets, maybe like scrapers, there's nothing that I know of to detect that. I'm not sure. Yeah, sorry. Any other questions? Cool. Thanks, guys.